let's refresh our memory on the process of long division. So if we want to take 1,342 and divide it by 12, we first focus on the first two digits, and we think about how many times does 12 go into 13. The answer would be 1, so above the 3 and the 13, I place a 1. And then I take that 1, I multiply it by the divisor, which is 12, and put it under the 13. So 1 times 12 is 12, and then I subtract. 13 take away 12 leaves me with 1. I'm going to bring down the 4. So now I'm thinking about how many times does 12 go into 14. Again, the answer is 1. So I put that up top. I take 1 times 12, put that under the 14, and subtract. I bring down the 2, and I think, okay, 12 goes into 22 how many times? Again, only once. So 1 times 12 gives me 12 to put under the 22. I subtract, and I have 10. So at this point, I'm at the remainder because 12 does not evenly divide into 10. So instead of going to decimals, we're going to keep all of our answers exact and leave it as a fraction. So you take your remainder and put it over your divisor. So it would be 111 and 10 twelfths, but we have to reduce because 10 and 12 are both even. So it's 111 and 5/6. We're going to apply the exact same process with polynomials. So in example 1, we're taking x cubed plus 5x squared minus 7x plus 2 and dividing it by x minus 2. So we're going to start by focusing on this first part of it, but specifically on the first terms to get us an idea of how many times it goes in. So what I'm thinking about is, what is x cubed divided by x? How many times does x go into x cubed? And the answer is x squared, because remember your exponent rules, you would subtract 3, take away 1, leaves you with 2. So you're going to put that up top, lining up your x squared place value column. So then we take x squared, and we're going to multiply it by every term of the divisor. So I take x squared times x, and I get x cubed. I take x squared times negative 2, and you get negative 2x squared. And now you're going to subtract all of that. So we have x cubed take away x cubed, which is 0. They've been eliminated, and that's your first checkpoint. If the place value column farthest to the left is not eliminated, you've made a mistake in what you put up top or in your multiplication. This farthest to the left place value column should drop out each time so that we just keep working our way over. 5x squared take away negative 2x squared is really 5x squared plus 2x squared, so you'll get 7x squared. And that's where you really have to be neat and take your time and understand that you are subtracting all of this. So you are subtracting the negative 2. When you subtract a negative, you're actually adding. So 5 plus the 2 gives us 7. So we bring down our next place value column, so minus 7x. And again, I'm focused on my first terms. So I'm thinking, all right, what is 7x squared divided by x? Well, 7 divided by 1 is 7, because the unwritten 1. And x squared divided by x leaves us with x. You subtract the exponents, 2, take away 1, leaves you with 1. So I'm going to put, it's positive, so I'm going to put plus 7x up top. Again, be sure to line up your place value columns, x's over x's, x squareds over x squareds, and so on. And now I'm going to take 7x and multiply it by every term of my divisor. So 7x times x gives me 7x squared. 7x times negative 2 gives me negative 14x. And now I subtract. So 7x squared minus 7x squared is 0. They've been eliminated. And again, another checkpoint, that place value column has to drop out, or I have to stop and rethink somewhere I've made a mistake. And then 7x take away, negative 7x take away negative 14 is really negative 7 plus 14. So you'll get positive 7x. Again, you really have to take your time here and think about all your signs. You've got negative 7, you're subtracting negative 14, so that becomes plus. So negative 7 plus 14 is positive 7x. Bring down your next place value column. So now I'm thinking, okay, 7x divided by x. That's going to be 7, because 7 divided by 1 is 7, and x divided by x is 1. If you subtract their exponents, you'd get 0. Anything with a 0 power is 1. So it's just 7, so I put plus 7 up top. And actually, I'm going to move this out of the way, because it's going to end up running into my remainder. So again, I took 7x divided by x and got 7. So I put my 7 up here, and I'm going to take this times each term of the divisor. 7 times x, 7x. 7 times negative 2, so negative 14. And now I subtract. So 7x minus 7x is 0. They're eliminated, so that was another checkpoint. Eliminated the furthest to the left place value column. Now 2 take away negative 14 is really 2 plus 14, or 16. And now I know I'm at my remainder because 16 does not divide evenly by x. So I take this remainder and I'm going to put it over the divisor. So I add on plus 16 over x minus 2. So that is our quotient. We're going to skip this generic rectangle and come back to it later. It's another method to do this same problem. But for now, we're going to move to the next example and take another look at how to do long division. Okay, so again, you're going to start by focusing in on your first terms, and you're going to think to yourself, okay, 2x cubed divided by 2x. So what would that give me? Well, 2 divided by 2 is 1, and x cubed divided by x leaves you with x squared. So 1x squared, or just x squared. And again, line up your place value columns. So put the x squareds over the x squareds. And now take x squared times each term of the divisor. So x squared times 2x gives me 2x cubed. X squared times 1, x squared. Now you're going to subtract all of that. So 2x cubed, take away 2x cubed is 0. I've eliminated that first place value column as I wanted to. And now negative 9, take away 1x squared, leaves you with negative 10x squared. I bring down my next place value column, which is the plus 7x. And I'm thinking to myself, okay, what's negative 10x squared divided by 2x? Well, negative 10 divided by 2 is negative 5. X squared divided by x leaves you with x to the first. So you're going to put a minus 5x up top. And now you take negative 5x times each term of the divisor. So negative 5x times 2x gives you negative 10x squared. Negative 5x times 1 gives you negative 5x. And now we subtract. So negative 10 take away negative 10 is really negative 10 plus 10, which is 0, which is good. I need to eliminate that place value column. And then 7x take away negative 5x is really 7x plus 5x, so you get 12x. And then you bring down your next place value column. So now I'm thinking, alright, what is 12x divided by 2x? And so 12 divided by 2 gives you 6. x divided by x is 1. So it's just 6, so I put plus 6 up top. And I take that 6 times each term of the divisor. So 6 times 2x is 12x. 6 times 1 is 6. And I subtract. So 12x take away 12x, they eliminate. 6 take away 6, 0. So I have no remainder, and I've finished. Here is the quotient. So 2x cubed minus 9x squared plus 7x plus 6 divided by 2x plus 1 equals the whole polynomial x squared minus 5x plus 6. So we'll do one more example with long division, and then we'll take a look at what this other method is. Okay, so the first thing that I want you to notice is that in your dividend, the expression inside, we have a gap. We go from x cubed down to x. There's no place for the x squared, and we're going to need a place for that. So rewrite the problem and fill in the gap with a 0x. It will really save you as far as organization goes. So just try and always take notice as to whether all of your place values are represented. If they're not, then fill in the gaps with 0 and whatever, x to the whatever power. So again, start with your first terms. So you're thinking 3x to the 4th divided by x squared. That's going to give you 3x squared. So it goes over the column we just created, the gap filling column, because they're x squareds, and now you're going to take that times each term in the divisor. So if I do 3x squared times x squared, I get 3x to the 4th. 3x squared times negative 3x gives you negative 9x cubed. 3x squared times 5 gives you 15x squared. So now we subtract. 3x to the 4th, take away 3x to the 4th gives you 0. We've eliminated that place value column. Negative 5x to the 3rd, take away negative 9x to the 3rd is really negative 5 plus 9. So that gives us positive 4x cubed. 0 take away 15 gives us negative 15x squared. And then we bring down our next place value column, plus 4x. So now we have 4x cubed divided by x squared, and that's going to leave us with 4x. So 4x times all of this gives us 4x cubed minus 12x squared plus 20x, and we subtract. 4x cubed, take away 4x cubed is 0. I've eliminated that place value column and checked off another checkpoint. Negative 15 take away negative 12 is really negative 15 plus 12, which gives us negative 3x squared. 4x take away 20x is negative 16x. And then we bring down our next place value column. So now we're thinking negative 3x squared divided by x squared, which gives us negative 3. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is positive 9x. Negative 3 times 5 gives us negative 15. And we subtract. So negative 3 take away negative 3 is really negative 3 plus 3, which is 0, so they're eliminated. Negative 16 take away 9 gives you negative 25x. Negative 6 take away negative 15. It's really negative 6 plus 15, so you'd get positive 9. I know this is my remainder because the degree here is smaller than the degree here. X does not evenly divide by x squared. So I'm going to take this whole thing and put it over this divisor as my remainder. So I say plus negative 25x plus 9 over x squared minus 3x plus 5. So that's the method of polynomial long division. Polynomial long division works for every single division problem we could give you. Let's take a look, though, at a secondary option. So we're going to go back to the first example and take a look at what that generic rectangle is all about. Alright, so in example 1, when we did x cubed plus 5x squared minus 7x plus 2 divided by x minus 2, we got this, x squared plus 7x plus 7 plus 16 divided by x minus 2. So we know that's what we should get as an answer. Let's take a look at another way to get there. So we call this the generic rectangle method, or the CPM method, just because the CPM curriculum is what introduced it to us as teachers. So you can use a generic rectangle to multiply. You can also work backward and use it to divide. You're going to take your divisor, the thing you divide by, and put it down the left-hand side of a generic rectangle. So because our divisor has two terms, we need two rows in the generic rectangle. Then you're going to take the first term of the dividend, the value you're dividing into, and put it in the first box. So I fill in x cubed. And now I start to work backward. I'm thinking to myself, x times what gives me x cubed? Well, the answer is x squared. So then I take x squared and I multiply it by negative 2 to fill in this bottom box. So x squared times negative 2 gives me negative 2x squared. And we know in generic rectangles that the right diagonals are like terms, and so they would add up to combine to give you this value. So these two boxes have to add to positive 5x squared. So now I'm thinking, what do I need here so that when I add negative 2x squared to it, I have positive 5x squared? The answer is 7x squared. So 7 take away 2 gives me the positive 5x squared. And now I work backward. X times what gives me 7x squared. The answer is positive 7x. So 7x times negative 2 will give me this box, which is negative 14x. And now I'm thinking, alright, negative 14x plus what would give me the negative 7x? And it's positive 7x. So that positive 7x plus negative 14x, or 7x take away 14, gives you negative 7. So x times what gives you 7x? The answer is positive 7. So 7 times x, 7x, 7 times negative 2, negative 14. So now these two boxes would have to combine to give me 2, which means I would need 16. So that's 16 take away 14 is the positive 2. And I work backward and think x times what gives me 16. But I can't, it's not a whole value, so I know I'm at my remainder. So I say plus whatever's in this final column is your remainder. It's just 16. So we put that over the divisor, which is x minus 2. So that you get your final answer, x squared plus 7x plus 7 plus 16 over x minus 2. Exactly what we got by doing it the polynomial long division method. So both the generic rectangle and polynomial long division work for any division problem we could give you. So technically you only need to know one of them because either of them will work all the time. But it's not a bad idea to know them both so that if you get stuck on one of the methods, you could try the other method. Let's see how this generic rectangle process works for the second example. Okay, so remember that when we did the second example, we got a whole value polynomial, no remainder. We got x squared minus 5x plus 6. So keep that in mind. That's what we should get when we do it with the generic rectangle method as well. So we take our divisor and put it down the left-hand side of a generic rectangle. Because there are two terms in the divisor, we need 2 rows in our generic rectangle. The number of columns is not easily predicted from the beginning, so you just kind of leave it open and add more as needed. We're just giving you kind of a generic box here. You may or may not need all of the columns. Fill the first term of the dividend into this first box. Now we start to work backward and think 2x times what is 2x cubed? The answer is x squared.